Well, I know, but the example I used before was if an anomalous observation is to be seen, then it would falsify your theory, right? So, right, exactly. So if for say where there's high redshifted objects in front of highly blue shifted objects, and the objects are actually connected, that falsifies the Big Bang, right?
No, no, I don't. First of all, let me put it this way: general theory of relativity.
It is.
It's said that our universe is filled with billions of galaxies, but how far away are they? Astronomers calculate galaxies' distances by measuring their redshift. The most redshifted galaxies are said to be the most ancient and remote. But recently, astronomers using the Hubble Space Telescope have observed galaxies that are too ancient, too close to the Big Bang. The mystery is that these galaxies did not have enough time for gravity to create the structures we observe.
In the conventional theory, one of the problems they have is gravity forming galaxies so soon after the Big Bang. That's because gravity is a very weak force. In the electric universe, you are organizing material by electricity and magnetism, which are vastly more powerful than gravity and are able to form these kinds of structures in very short times. Several astronomers analyzed a new group of over 1,600 galaxies, analyzed them for shape and color. They sorted them into the Hubble sequence, which is an observational category. The galaxies come in elliptical shapes and in spiral shapes. These astronomers who analyzed these galaxies also calculated their distance based on the common assumption that redshift is a measure of distance, which they assume is caused by the expansion of the universe. The redshift, interpreted as a measure of distance, means that the higher the redshift of a galaxy, the farther away it is. And because of light travel time, the farther away it is, the longer the light has been traveling, and therefore the galaxy would be from a younger time in the universe. It would be closer to the Big Bang. A lot of the galaxies they studied went back to 11.5 billion years ago, so they would be only a couple of billion years after the Big Bang. Another assumption is that gravity is the only force that organizes the universe. So after the Big Bang blew out kind of a fog of matter, it would take a certain amount of time for gravity to organize this matter into galaxies. According to conventional theory, they wouldn't expect gravity to be able to do this in only 2 billion years. Discovering that there's a Hubble sequence all the way back to 11.5 billion years ago creates difficulties for explaining it with gravity.
Astronomers typically classify galaxies by their shapes: ellipticals, lenticulars, spirals, and irregulars, all said to follow an evolutionary sequence. Since this classification was first named by Edwin Hubble, it's called the Hubble sequence. But how well does this convention actually describe galactic evolution?
One of the quotes from the group is this: clearly, the Hubble sequence formed very quickly in the history of the cosmos. It was not a slow process. Now we have to go back to the theory and try to figure out how and why. This isn't entirely unreasonable because it's politically and economically almost impossible to consider a fundamentally new theory. If you look back in the history of science, the fundamental conceptual changes are rare because the benefits are often generations removed from the initial questions, and the questions don't really matter for daily life. They won't change the price of eggs. So there's a lot of incentive to just tinker with a theory and try to find something that'll work reasonably well. And the more involved the theory gets, the more opportunities you have for tinkering with it. So getting new ideas considered is difficult, to say the least. But when a theory becomes so encrusted with these patches and these tinkerings, it begins to become a nuisance.
what that is.
No, because
and they don't apply it to themselves when these theories are so big and dogmatic.
No, not all.
That,
And you,
right.
quite a dude. I'm friends with Dr. Hugh Ross, right? You know who he is, correct?
No, not really.
He's an astrophysicist, a very famous astrophysicist, Dr. Hugh Ross. Go look him up.
Hugh, oh,
Yeah, I mean, if you had any kind of, wait a second, if you had any kind of evidence that falsified the Big Bang, he'd be the first person I ran it through. And
yeah,
I guarantee you have no evidence that falsifies the Big Bang because I've been down this route with people. I don't think you understand what the Big Bang even is. Trust me on this one. I guarantee it. I'll be very surprised if you can tell us what the Big Bang Theory is. I tell you what, I'll even eat my words. I'm going to say, Grim, God, you really surprised me. You do actually understand. In a single sentence or less or so.
Something from nothing.
So you see this today, and a lot of people are unofficially expressing dissatisfaction with the current state of astronomy and actually a lot of the sciences. The problem with patching the existing theory is that they keep coming up with new, what we call helper assumptions, fudging. This would be things like dark matter, dark energy, super compressed matter, like in black holes and neutron stars. There's no laboratory evidence to support any of these new things. They're just added on assumptions in order to save the theory, in order to make gravity work. As you see these early condensations of matter and high energy sources, conventional gravity can't do that. So they have to get a lot more gravitational energy into these areas to produce what they see. They do that simply by pressing a lot more matter into a lot smaller space. If they take into account the electric force, you can get this much energy in a small space simply by powering it with electricity.
Tell everybody what the Big Bang Theory is.
Something from nothing. Zero source, zero.
For many years, cosmologists have relied on the idea that the universe formed spontaneously, that the Big Bang was the result of quantum fluctuations in which the universe came into existence from nothing.
You know who he is, correct?
No, not really.
He's an astrophysicist, a very famous astrophysicist, Dr. Hugh Ross. Go look him up.
Hugh, oh,
Yeah, I mean, if you had any kind of, wait a second, if you had any kind of evidence that falsified the Big Bang, he'd be the first person I ran it through. And
yeah,
I guarantee you have no evidence that falsifies the Big Bang because I've been down this route with people. I don't think you understand what the Big Bang even is. Trust me on this one. I guarantee it. I'll be very surprised if you can tell us what the Big Bang Theory is. I tell you what, I'll even eat my words. I'm going to say, Grim, God, you really surprised me. You do actually understand. In a single sentence or less, or
In a single sentence or less, okay? Explain the Big Bang Theory. In a single sentence or less. So I go right to my problem with the Big Bang Theory. You hear what he's asking, right? Tell me about it. Tell me it like it's an ice cream flavor. You know, strawberry. Clownfish.
or so.
something from nothing.
I just said something from nothing. Because we can get to why. But man, this guy. Silly guy with the rudeness.
Theist explanation.
I'll even eat my words. I'm going to say, Grim, God, you really surprised me.
Something from nothing. Zero source, zero. Einstein says
There
to
you
Ricky,
go. He has no idea what the Big Bang Theory is. Did I call this one? Give me a
Look at him. What was that all about? Explain it in 2 words. What? And I tell him my problem with it, which isn't just my problem. It's a big problem. Because you're still trying to say that it came from nothing.
That's a great theist explanation.
all this hot dense matter came out of nowhere.
Thank you very much.
Well, no,
It's not the beginning of anything. It's not even real.
had to like simplify it in the most dumbing down type of.
That's
and you did it wrong.
That's why I tried to do that and make it as dumb and.
See, I'm still trying to be nice, even though I know they're being completely fucking rude and attacking and, you know, antagonistic.
Simple as fucking you can
That is
possibly
so,
make it.
Grim, that is not even simple. That's so practically wrong. That is potato.
See, what are we on the schoolyard? Was that funny? I mean, that's literally something that my kids would say in middle school. You know, that's
You
weird.
might have just answered potato, and I would have given you a higher score.
Oh, he would have given me a score.
If you had said something from something, you would have been more correct.
Yes,
As King Crocodile would say, that's not even wrong.
not even wrong.
Yeah.
Right. Yeah, I got
So,
it.
Steve,
I was
Steve,
over. I was over.
Yeah, but like if I were to continue talking, I would be talking about the actual mechanics of the idea instead of just the stupid thing that I just said that you're making your stupid little judgments and running your little commentary. Right, but the model describes basically how the universe expanded from like a very super high density and high temperature state, right?
But that is not nothing.
That is not.
No, that is not nothing. But you said give me a sentence to describe it, and I'm saying where did the super hot dense material even come from? Nowhere. How did it come from nothing? Okay, so it's not that my argument is wrong or my explanation was wrong. It's just that your very limited understanding of where my approach is coming from is misleading you into thinking that I am wrong. That's all. It's your limit, not mine.
Nothing.
Well,
Right?
no, it offers like
But it seems like the ultimate goal here, because look at how he has the giddy on the face right now. Well, I'll change all that in a minute. That'll changes quick when he starts realizing that I know what the fuck I'm talking about, and he's getting roped up in his stupid, attitude towards me. So he's gonna have to start using other tactics like muting and interrupting and having his friends gang up and interrupt and help him when he stutters down and all of this kind of stuff. So you got to remember this is a circle jerk right here. These guys, they're literally with their little appeal to authority issues and all that kind of stuff. It's disgusting.
a huge range of phenomena and things that you're
I'm so frustrated.
what you're seeing, including light elements, cosmic wave background, large scale.
Look at him talking over me, burping. Like he's going to have the gall to complain about somebody talking over him or interrupting him in a moment. And I'm just saying the level of disrespect that was being put on me already from the gate, it's more of a reflection on him than it was on me. But I just wanted to go in there and make it be known that this little campaign to, dismiss some of the things that are actually changing our science books and textbooks today. This is actually changing. I mean, last year they would never have admitted to, the electrical asteroids or, electric comets or, anything like that. This Steve McRae and them. But, while I'm telling them about it, I'm crazy. Oh, but now that the article comes out and NASA admits to it, oh, yeah, it was expected. They know all about that now. Yeah. Like, what? I mean, I remember you telling me I was a fucking moron for trying to explain the mechanism to you and let you know that it's even possible for that to exist just last year. And now that you see that it's part of mainstream, you already knew that, Steve. You already knew that. You and your buddy, what's his name? Whatever you said his name was, your astronomer buddy, who, you'd have had to, it would have been passed by him if there were any problems with the Big Bang, they'd have ran it by him. Steve, come on, bro. You acting like this guy doesn't know about these arguments or something. Are you bringing this? It's a logical fallacy for you to bring around an imaginary friend with you and appeal to his authority and keep bringing him up in the middle of an argument about something that you clearly don't know what you're talking about. I'm just saying, Steve, I thought you were a debate guy, but you're using all the wrong tactics. I can see the blue screen on your lenses right now. You're Googling. That's what's cute. There's no blue in any of these squares. See? You're Googling, Steve. All these squares are not blue.
Breathe for a second. Brandon.
Breathe as he's reading.
This is, I have this thing up for you. Do you want to go down this
exactly
route?
what I'm talking about.
Grim,
It's result of this
Grim,
single
Grim, you take a fucking breath.
Wow, man. You're talking over me, being disrespectful. I'm still like, what have I ever really done to you for you to talk to me that way? Because I've really never, ever done anything to him. It's this attitude came from him after he saw me destroy his little boyfriend, Artist, in a debate on the GMOs and glyphosate issue. He actually wants to work for Monsanto. He wears a Monsanto t-shirt, and he's promoting Monsanto as innocent and good, all natural, wholesome, helping hand. It's like the really ridiculous stuff. As if there's no public record of any malfeasance or any, anything going on with Monsanto at all. There's no, studies that have been falsified and not repeated. That's basically falsified. If you can't repeat your own safety study, you falsified it. I don't care what you thought you were doing. And then they, all of that kind of stuff. Argue with me for about, year and a half or something, trying to control debate rooms. Because if you go into their debate room, this happens. You can see I'm clearly trying to talk, and I'm the guest. They're always there, right? I'm the guest. So, I'm the one with something new to talk about. Why not let me talk for a moment, right? What are you really scared of? Why is it some gleeful moment to try and bash somebody down like a ring of monkeys, and a new monkey walks in and you have to play pecking order, bashing down games? That's low level vibratory bullshit right there when you're doing that. I'm going in there and I'm literally just trying to, even repair. They've all been rude to me before, and I'm trying to go in there and not start from where we left off and just start over. Every time I do this, that's what I'm trying to do with these guys. I'm not trying to, focus on their irrational behavior, even though they pretend to be on the high horse, right, while they're doing it, which is, I don't know if that helps them sleep at night or if it makes it more, justifiable for whatever in their minds or whatnot, or if it's just literally fun to be like a group of mob, thinkers, group think, and appeal to authority. I'm going to prove it right here. I mean, you guys will see clearly Steve has no fucking clue what he's talking about. I mean, he has a clue what he's talking about, but he has no clue what I'm talking about. Put it that way. Because when he describes a capacitor here later on, it's hilarious because obviously I'm talking about capacitance in plasma fields in space, being that I even used, NASA and their spacecraft as the example for the tool of detection for these things, right? So I'm not talking about sitting in a machine shop making capacitor parts with, a dielectric paper, he says, but it could be any kind of insulator in between, whatever. But he's talking about material insulators and material capacitors, things you would put in a remote control car. And I'm talking about field dynamics, magnetohydrodynamic waves, the Alfvén wave, which is a magnetohydrodynamic wave, which is literally the reason why magnetohydrodynamic wave, the word, was invented, because of plasma and field dynamics. Hannes Alfvén invented the word magnetohydrodynamic wave to originally speak on plasma, and then other feral fluids and things like that later, okay, because his work was with plasma. So it's interesting here how you'll see Steve tell me, what is a magnetohydrodynamic wave? And then try to bring me to his idea of what a magnetohydrodynamic wave is, which is very limited and does not include plasma, which is what I was talking about, which again proves clearly that Steve had no fucking clue what he was talking about. And his pompous behavior to be so rude and dismissive to everything I said shows the irrational, his irrational cognitive reasoning. That's exactly it, all that this is. You know, I smoke weed, therefore I must be stupid. That's irrational, Steve. And you'll see here in a moment, guys. I'll show you.
Brandon, do you want to go down this rabbit hole with cosmology?
Cosmo, sure, I can go down any rabbit hole. I really don't mind.
All right, I mean, I just want to make sure because I can go down any rabbit hole too. People know I'm pretty versed in a lot of different areas.
I mean, I'm not going down his rabbit hole. Yeah, that's gross.
No.
Well, there's a little rabbit on the screen, so.
I was gonna say there's quite literally a rabbit right there.
So Grim,
You guys, you're eliminating the idea that EM fields, which are 1,000 billion times stronger than gravity, by the way, you're eliminating the idea that they could be out there structuring and organizing the orbits and structuring matter and whatnot. And you're adding ad hoc ideas like dark energy.
See, I can see him. He's reading right now, and he's going non-ferrous materials. He doesn't understand what plasma is, obviously, or how it behaves. He might know the definition for plasma, but if you listen to what I'm saying he doesn't understand what plasma is. See, knowing the definition for a thing and understanding what the thing is are two completely different things. And you'll soon find that out by listening to Steve McRae and his bullshit diarrhea mouth.
In dark matter, try and fill anomalous behaviors, right?
As if I don't know my own name. While I'm talking, he feels the need to say Graham. You know? Come on, bud. Come on, buddy. And then all this oversighing me and trying to just take over the mic.
Hey, Grim, you have to breathe.
I have to breathe? Is he projecting right now, folks, or sublimating?
NASA has just detected the alpha. I don't have to breathe. I'm talking about. Just stop talking over me for a second.
Repeat and repeat. He keeps repeating himself. He said, Grim. You have to breathe. Grim. Could have just let me talk that whole time, right? Instead of doing all that. What are you afraid of, Steve? See, I'm trying to point it out. He's afraid to let me talk, and there's a reason. There's a reason why. Because he's already vested in the idea that I'm an idiot. He thinks he's already shown that I'm an idiot. So if I turn this around, which is the subject he thinks he's already shown that I'm an idiot in, right? If I turn this around today, right now, in front of his friends, Steve's little ego is going to be pooped. He's going to be pooped. And then it's going to be known that he has no dignity because he will not even say, oh, well, I have a newfound respect for you as I'm wrong. And I apologize for my 2 or 3 years of calling you all kinds of bullshit names and saying you're a fucking moron. See, he'd have to take all that back, right? And then that's manhood right there. But you got to remember, we're on the school playground in Steve's hangout. So there's no manhood in there. You'll find that out when this happens. Like you'll see.
You're being very disrespectful, man.
I'm not trying to
defend a little bit of the position.
Jesus.
Now, all I'm saying is you're being very disrespectful, and I'm only trying to defend the position. And now he feels the need to a screaming outburst at me. I'm just telling you, if you guys think that this guy's intelligent, you got another thing coming. Intelligence isn't just about how you formulate your words. Some people can formulate their sentences very well and still be completely fucking ignorant. That's not just the only bar of intelligence that you need to be looking out for. It's people who know how to work out the mechanics of the ideas that are important, and get overlooked. People like us who are out here really doing cutting edge research, knowing that both sides of the argument instead of just believing dogmatically in black hole math like this knucklehead.
To be out there structuring and organizing the orbits and structuring matter and whatnot. And
Non-ferrous.
then you're adding ad hoc ideas like dark energy and dark matter to try and fill anomalous behaviors, right?
You have to breathe.
NASA has just detected the alphemus. I don't have to breathe. I'm talking about. Just
You
stop
can
talking
breathe.
over me for a second. You're being very disrespectful, man.
I'm not trying to
trying to defend a little bit of a position.
Jesus fucking Christ. You're high as fuck. I don't want you to shotgun, okay? Because shotgunning does no good to anybody. I can explain each one of these things in order that you
He just shotgunned.
bring them up. But don't shotgun, because this is what Eric does.
I don't even know who Eric is. So there's another logical fallacy of comparing me to somebody else that, as a ad hom kind of attack.
And this is what other people do, like Neffy. And I cannot sit here and address 5 million things. Let's talk about this in order that you bring them up. Okay? So one of the first things you brought up is these EM fields. Okay? Non-ferrous material are not affected by EM fields.
Okay, so there you clearly heard it, right? Steve has no fucking clue how EM fields are sustained over plasma, charged plasma. No clue. Even though I just want to slap him in the mouth, right? How about this, Steve? It's real simple. Have you ever seen a tube of neon? A neon tube. Just one electrode on one side, an electrode on the other side. You pass electricity through the gas. How's it get there? There's no wire in the middle. How's it get there, Steve? Anyway, well, depending on the gas, argon, you might have a mercury vapor. Neon, you need nothing. Noble or not. So there's a big limit here. The guy is it's a speed limit sign, 5 miles an hour, slow children, right here on his head. And he's telling me that I'm the Riri. I mean, I might be a Riri in some areas, but just not this one.
There you go. Done. Okay, move on to the next one.
Wait a
So
minute.
you cannot sit here and address 5 million things. Let's talk about this in order that you bring them up. Okay? So one of the first things you brought up is these EM fields. Okay? Non-ferrous material are not affected by EM fields. There you go. Done. Okay, move on to the next one.
No, Steve, let's not move on to the next one because you're completely wrong. This is a prime example of Steve McRae, the pigeon, walking around, knocking over all the chessboard pieces, pooping on the chessboard, and dancing around on it as if he just won. That's it right there. That's what he did. And the guy is clearly ignorant to the mechanics of plasma and the plasma dynamics.
Go ahead. Jesus. So EM fields have nothing to do with non-ferrous material.
Funny guy. Pete and Repeat were on a boat. Pete fell off. Who was left? Repeat. What a dummy.
You can't by decree say.
I don't believe. See, now I was muted, right? He had me muted so he could do that little shotgun the whole time.
You win an argument. What is plasma?
He never said that.
He never said that. Thanks for trying, but you lose too, Mr. Goofy Barney, because he literally just said done, as if next, moving on. He did not win that argument, so he's not going to go done, next, moving on, obviously. So yeah, he did just do that, and you are really apologetic to his ridiculousness for some reason.
Yeah, first of all, I didn't win the argument. Second of all, wait, are you acting?
Just claim done. You walked around on the chessboard like a pigeon, knocking all over pieces.
Oh, I did say that.
Talking about.
Okay, so you're claiming that
You don't even know what you're talking about. Plasma permeates our
plasma is.
Yeah,
I just had
plasma is a conductor of
I just had a
electricity.
plasma physicist.
Right.
I just had a plasma
Okay, so
physicist on my
good. So
channel.
then you
Grit
understand
is
that
very,
NASA
very high.
You see how he won't let me talk, and then his buddies are like going to jump in on me too. and I'm still trying to say the first sentence that I was trying to say that he keeps interrupting me in the middle of.
You're high as fuck, and I'm done.
No, I'm high as fuck, right? And they're done. I mean, I'm just being so rude to them, aren't I, guys? I mean, I'm walking around there acting and all kinds of crazy, calling him names and, cussing at him and yelling at the top of my lungs at him like, or is that him? Oh, yeah, that's him. He's doing that. Oh, let's get back to reality.
One more chance before I get rid of
I'm
your
not
ass.
being rude to you, Steve.
Grim, you cannot just throw this shit out there. Now, do you agree?
You're talking at me instead of to me,
Because
Steve.
you're an
I don't
idiot.
like that.
We all know this. This is
Because I'm an idiot, he says, and we all know this. I feel like you're really afraid, Steve. Something's wrong, man. Like you're afraid to have me not be seen as an idiot. So now you just gotta editorialize it, say it.
All you have is ad hom so far. I've explained myself. If you understood the plasma dynamics, then you'd understand what I'm talking
about. You understand plasma physics? I tell you what, I will.
Yeah, a little bit. I sure do.
Great.
Watch this. Watch this. This is the weakest form of argument, folks. You're about to witness it right now.
This information from Anthony Pratt.
I will set you up.
Which I just did it too.
Listen to me.
I will set you up as a plasma physicist. I will set you up as a plasma physicist. And you guys come in. Both of you guys describe plasma physics, and we'll see who understands it.
Right. And you're only worried. Yeah, we both. Then we'll see that we both understand.
So what is plasma?
All right.
What is plasma?
See, listen to you, not listening to me.
See, he needs to ask me what plasma is, as if the definition for plasma is going to basically explain, which it actually does, what it is. And by the way, I've told Steve what plasma was many times before this too. So that's why I'm like, dude, again, why are you? This is a tactic, right? This is a clear Delphi tactic to divert the conversation from the point I'm trying to make about the material we're discussing to something where he can actually divert the conversation into another, like I said, just a distractionary point of another chance to find rudeness, to be more rude.
We've gone over this 1,000 times. What is plasma? Free electrons, ions.
Okay, so what is it?
Yeah, it's an ionic gas. It's removed of its electrons.
Gas.
Yeah,
like the state of gas.
Well, it was, and now it's plasma. It's electrified.
Electrified. So it's electrified. So it means it produces electricity.
In the state that we're speaking about right now. Okay. Have you heard of the Alfvén wave? Hannes Alfvén.
No idea.
So, the father of plasma science, of physics. You have heard of him? Okay. That's cool, but that's all right. It's okay not to know stuff.
I agree. Dude.
Right. So now that we've established that you actually don't know what we're talking about, especially the Alfvén wave. Alfvén wave is a kinetic wave. If you'll listen for a second, you'll learn. Okay. The Alfvén wave is a kinetic wave in plasma, showing that.
See the blue screen on his glasses? It's a dead giveaway. He's Googling again. Mr. fucking knows everything he's talking about, and he's still Googling to try and argue. Not to find any relevance in what I'm saying, obviously, but to argue like a little girl.
The plasma also has capacitance, which means it's a capacitor and can hold a charge. Okay.
Yeah,
so we have,
wait.
Right. So the charge capacitance.
Ooh, wait. So I can tell one word he understood: capacitor. Now he's going to think of a capacitor in a remote control car made of materials. And not the Alfvén wave, which proves that the plasma cloud field, whatever it is has capacitance, acts as a capacitor, not as it's built into a man-made capacitor like this fucking moron sitting here trying to think. Oh, so dumb.
The charge potential differences, we have discharges in EM fields and electromagnetics. Right, because without the magnetics, there wouldn't be.
Now you're jargon bombing. Okay, I know what it.
No, I'm not. I'm just trying to talk through your over talking me.
So what is the dialectic in the capacitor then? Is this in your example? Give me what is actually the dialectic?
All right, I break it down for the terms that you might be expected to.
Again, Now we're going to talk about a physical capacitor, which he's changing my subject. I'm talking about capacitance in plasma. Now he wants to break it down to what other people already understand about a physical capacitor, which is more proof of his very limited understanding of what we're talking about. But you sure wouldn't get that idea that he has a limited understanding of what we're talking about, not from him or his approach or the way he's speaking. He really thinks he knows everything about this already and that there's nothing else to be known. Therefore, anything he's saying must be correct and anything I'm saying must be incorrect. But that's, again, his own irrational logic at play.
Understand what is the dialectic in your capacitor?
Again, you can say dialectic, but the real word that you're looking for is dielectric. So let's,
When we're splitting magnetism and the electric.
You hear me giggling and saying the word electric on purpose because I'm like, okay, he doesn't even know the words we're using. He misread that. He's reading it right now, misreading these arguments.
What is you're calling it a material, but it could be actual magnetism. It has dielectric properties as well.
What is a dialectic?
Faraday.
Wrong question. A dialectic, that would be a synthesis, an antisynthesis, and a thesis, an antithesis, and a synthesis. That'd be like a Hegel's dialectic. But we're talking about dielectric, Steve. Come on, buddy. And I know you think you know what you're talking about. You're just using the wrong word. But you're thinking of a dielectric as a piece of paper insulator in between two opposing currents. All right? That's not what we're talking about here, Steve. We're talking about magnetism having dielectric properties. That's the mechanism of the dielectric in the field that I'm discussing, which you will not allow me to discuss my topic. You're trying to make it, you're going to try, in a second, he's going to try to bring it to nuclear submarines, which they're not working with plasma dynamics because he doesn't understand magnetohydrodynamic wave like he thinks he does. He thinks he does, though. That's what's cute.
Quotes.
Yeah, what's a Faraday? What's a Faraday?
And I don't hear him right now, by the way.
No, it's just quoting something Faraday said. As magnetism.
I'm quoting something Faraday said.
Is a dielectric.
Yeah, you're dielectric. Fuck, because you don't know what the hell you're talking about. Can you even tell me what?
Hey, Brendan,
You
are
can't
you
even hear
enjoying
me.
this?
Magnetism is a dielectric field. That's what I'm trying to say.
Brandon,
Yeah, but what's your real question?
So
I know,
so
but
neurotic-
anybody who knows about plasma knows that I know what I'm talking about. That's
no,
the
they
thing.
don't. I have a plasma physicist, and right now will tell you that you're an idiot.
What? They're in your pocket?
No,
He'll tell you because he's your buddy?
You really? No, he's a plasma physicist.
Anthony Pratt? Is he Anthony Pratt? Is he Hannes Alfvén? Is he the father of plasma physics? Your guy is gonna tell the father of plasma physics that he's an idiot.
Are you gonna blow?
Repeating.
I mean, no, but he's going to tell you you're an idiot.
Yeah, you're an idiot. You don't know what the hell you're even parroting. You just spewing out shit like Ronnie does.
That's a bullshit, man. You just won't even look at what I'm saying. You just had a whole long conversation about people like you.
All right. So what is your diet?
He did. He just had a whole long conversation before this about people who don't listen to the other side of the argument, argue from ignorance, appeal to authority, all the things he's literally doing right now. And I'm what can I do? But just laugh.
What is your
You have a whole full conversation about people just like yourself. How they don't look at the other side of the argument. They ridicule. They argue from ignorance. All of the things you talk about.
All right, Grim, fuck off.
Why are you muting me?
Yeah, because you're not. I'm going to eject you in 1 second here if you interrupt me one
Fuck
more
off to
time.
me. I've not been rude to you yet.
Listen to my question. Either answer the question or get the fuck out. What?
Ask me a question.
Wow, this guy has got some control freak issues, huh? Like with the little bitty fucked up. I mean, what's going on with that? Talking to people like that. Still Googling too. Look at the blue.
Then
Can I? What in your example is the dialectic in the
There goes that word again. It's dielectric, dipshit.
capacitor? A capacitor has a dialectric.
You see me giggling? I have to put it on camera because that's another reason why he hates me. Look.
Right? What is a dielectric in your capacitor there?
Well, like I
Finally said it
it's
right.
When the
Made me smile, Steve. You finally said dielectric. Good boy.
magnetism and the electricity are separated.
Oh, Jesus fucking Christ. Did it?
All right. Did that not make sense to anyone else where the magnetism and the electricity are separated? Basically, the magnetism runs perpendicular to the electric charge. It's called the Lorentz law or Lorentz force or the Lorentz force law. Everyone knows this, Steve. And it's funny how, you know, I'm still trying to be polite. And you guys will see. I mean, I'm not trying to get kicked off here because I'm trying to prove a point.
Anybody understand that?
It's well,
Okay, no.
Now I'm like, okay, since he's yelling, does anyone understand that? Let me reformulate the way I said it for him to understand it better. Not because I'm incorrect, but because he doesn't understand.
Nobody understood that. Do you know what?
You're
Do you,
talking-
okay,
you're thinking
wait.
about-
It would be.
the actual mechanism would
I
be
have
the
another-
wall of electrons in a double wall.
I have another question. What is a farad? What is a farad?
I don't know what he's saying.
Coherency. What is what?
You're a fucking idiot. Get the fuck out of here. Bye bye.
I
You're
can't
done.
hear you.
Yeah, I don't give a shit. You're done. This is what
So
was
you
this?
clearly saw that I couldn't hear him. I thought he just said coherency out of nowhere at me. And I started thinking of all kinds of shit when he said that. What the fuck? Coherency? And then now he's saying, what's a Faraday? Come on, dude. Really? What's a Faraday? How many times do you want to change the subject, homie? What's a Faraday? Because I mentioned the man Faraday, you have to ask because you're on the Google page of what's a Faraday. Really? I mean, I don't see through you by now, Steve. That's the thing. You just Google Faraday because I mentioned Faraday. Then you say, what's a Faraday? First of all, I didn't know you said that. I'm an electrician, Steve. So, of course, we know that it's a measure of capacitance, right, Steve? But you're going to dance around and act like only you knew that, even though you know I didn't even hear your question. That is a very weak, there's a poor self-esteem involved right there when you need to actually take delight in false wins, when you take real delight in cheating. You cheated. It's not a real win. You didn't do anything there. And you put this power stance on where you put your hands behind your head like you're done and you're in a position of authority. Right? Look at the power stance or what he's doing there. And the smile as if, you know, it looks like a nervous smile.
Even about. What is he trying to prove?
This is why I said, Brandon, you want to go down this rabbit hole? Because he's an idiot, as you can tell.
Yeah, that was a rabbit hole that I was not expecting because of what I was expecting by a conversation.
That was a rabbit hole that I was not expecting. That, you know, you're not smart just because you're trying to sound intelligent, obviously. Because if you thought I was wrong, there's a clear right. It's clear and evident that you're ignorant and gullible. You believe that Steve was right from the argument that he presented. You're literally gullible. You're dumb too. And you're fucking alien-esque looking. Okay.
Based around the Big Bang Theory was something that was central to the Big Bang Theory. Went off on a different tangent and then went off on a tangent off of that on how the first tangent was somehow relevant.
You see what happens?
We were having a nice conversation. All of a sudden, Bugs Bunny got his carrot up his
Well,
ass.
that's why I wanted to take it down there for a second.
We were having a nice conversation, but all of a sudden Bugs Bunny just decided to get mad. You didn't call him an idiot or say a bunch of fucked up things to him or anything, and he was wondering why you were being rude or anything. It was just all of a sudden, I re-editorialize it for him, buddy. Tell him how it was. What happened? I think people are watching right now. They kind of know that you're full of shit. I didn't just all of a sudden get a fucking hair up
Okay,
my
but do what
ass.
happens when you have an idiot who's
Funny
high,
pun.
even
though.
more being an idiot.
Yeah.
He doesn't know what a
Was this?
I mean, that's like the 7th time you've called me an idiot, Steve. And you still can't prove it.
The electric world theory thing.
Yes.
The electric universe.
And here comes this dipshit acting like he didn't know what we were talking about. So he can clearly say, oh, yeah, that's dumb.
Yes.
Bullshit. Oh,
Yes. This is why I said.
okay, I'm glad I never went into that.
I was gonna say that's what I imagined whenever you were talking about
You have earlier. Yeah. And by the way, a farad is a measure of capacitance, how much something can store as a capacitor. The way a capacitor works, and he doesn't understand this, a capacitor works like this. You have two plates usually, okay? And it could be like wrapped around each other like an electrolytic capacitor, or just like metal plates or air plates. The middle in between them.
He had to say that I don't understand, when clearly we're not talking about what he's talking about. For some reason, he can't get that out of his head, that, or either that or he's straight up just fucking lying, trying to keep it to here only, so he doesn't have to think about plasma dynamics. Because where's the plasma in your capacitor? Since I'm talking about plasma, Steve, and you're trying to tell me what I'm talking about, where's the plasma in your capacitor?
It could be air gap, right? Or it could be something in there with like mica, or
that's a strange thing to say, air gap. What is air? Gas. What is gas electrified? Plasma. So it's a plasma gap, you stupid shit. I can't believe this guy's talking. I can't believe these people are listening.
a soaked what's called electrolyte solution with the paper, and that paper is called a dielectric. That actually is what maintains the charge differential between capacitor plates, and so I can have
somebody take care of that little creep in
so when I
the chat for me.
I
appreciate it.
Charge for much like that, or for example, you have a sinusoidal wave, the capacitance will start to discharge, and it'll continue to keep a voltage through there, and that's kind of what it'll do in like a rectifier circuit. If I wanted to like do an inverter to convert DC to AC,
Got a religious fanatic out here.
It keeps the voltage from going too low, because during the low points of the sinusoidal wave, the capacitor will start to discharge. That,
high five, buddy.
Those besides
I'm not capable of following this.
Well, not story short, Grimm doesn't fucking have a clue.
Yeah. Can you sum up what the claim of the electric universe is?
Yeah, Electric Universe started back when with a guy named Immanuel Velikovsky. He wrote a book called Worlds in Collision, which I actually read back in the early '80s. It was based upon the writings of a man named Zecharia Sitchin. Ever heard of him? Nope. Names should be familiar. All right. Well, Zecharia Sitchin claimed to be able to read reformed Sumerian mythos and Sumerian writings, and he developed this huge narrative of the Anunnaki, which is a race of aliens that mated with humans, and built this whole mythos on this, right? That Immanuel Velikovsky ran with. Some of the theories that he came up with is this were: one, Venus was an ejected comet from. Why is Grim back? Grim, you're high. You don't know anything about this stuff. What do
you said Zecharia Sitchin, man. That's not Zecharia Sitchin. Give me a second, okay?
Yeah.
Before we go stupid again, just give me a second, because you have a misrepresented idea of what they
really. Okay, correct me on this.
And I understood what a capacitor was. I thought you were asking in terms of what they're calling a capacitance. What we're talking about in plasma, a double-walled layer of plasma having capacitance.
Don't start again.
I understand like the standard definition of what a capacitor is, dude. And a farad is a measurement of capacitance. But I didn't even know you said farad.
Grim, don't go there again, please. I just want to hear what the base.
Look at his buddy trying to save him, right?
The base for the electric universe theory has nothing to do with any man named Zecharia anything. Okay?
Really?
That is Nibiru bullshit. Yeah, that is the reading of some Sumerian tablet bullshit. It has nothing to do with us, dude. Just put that somewhere else. That's not got anything to do with the EU theory at all whatsoever. That is some old fucking theistic bullshit, fairy tale stuff. That's nothing to do with us.
Okay, stop telling me what it's not. Tell me what it is.
Okay. I just had to defend what it was just called.
Do you know who Immanuel Velikovsky was?
Yes.
God, again, can we shut up, Steve? I mean, seriously? He just asked me a question, right?
Immanuel Velikovsky.
Jerk you around, I have to answer everybody's questions. It turns into some sort of a a misleading conundrum where we're not going to talk about whatever it is that I'm trying to talk about. And you like how I came in there with my plasmoid right in your face.
He had some proper ideas about electricity in space, but he was a little cuckoo too. And
we all agree. He got a lot of these things from.
It doesn't matter. We have NASA now. You believe in NASA?
Read any
Do you think NASA's really out there doing stuff? I do. And do you think they're measuring alpine waves? I do, because they did, and they discovered it. It's just only a couple of months old.
Did you ever read any Velikovsky?
Obviously, he's not listening to me, because I'm telling them this is only a couple of months old. This new data that just came in that you're ignoring. It's from NASA, dude. I mean, you have an appeal to authority. You should be clinging straight to that, shouldn't you? Or does it have to get run by your friend first in your pocket?
Yeah, no.
I did.
So what?
But I've read a thesis about Velikovsky.
Okay.
So it doesn't,
And what?
fine. I didn't read what he said, but I read what other people said about it.
Well, if he's crazy and he doesn't matter anyway, why does it matter if I read him or not anyway? Right? If that's what you're saying. Okay. Why would it matter? Because it doesn't. It doesn't originate. He's not the only one. That's just, golly, he just wrote a fucking book about
separating
it.
what I'm trying to say away from me. He keeps on parceling it into these little broken pieces of knowledge. You're not going to get the picture of what I'm trying to tell you if you keep letting Steve do this.
Well, then why don't you get to the picture?
Yeah.
I'm trying to. You ask me what the fucking
You asked me a question and Steve just fucking interrupted it.
what EU theory is. All they're doing is applying classic physics, plasma physics, which is existing here on Earth. It's not, pseudoscience. They're just applying it to things in space instead of using those gravitational models only, because so many observations refute the gravitational models.
Such as what?
Such as redshift.
Thanks for interrupting me again.
And
No, it doesn't. Okay, Steve. You King Steve by decree, who knows more than any other astrophysicist, who are still debating all of these issues and nothing is settled in science. But in Steve's mind, it's all settled science.
highly redshifted objects and behind. Yeah, it does.
Well,
interrupt me again, Steve. I swear, if we were on the schoolyard, I'd have been suspended from school that day.
Connected to highly blue shifted objects that are in front of them. Yeah, it does. It literally does. Then there's the
show me the physics
in the spiral galaxy.
Show me the physics.
Since the space age, we've discovered that the universe is composed of plasma, which has demonstrable electrical properties, rather than mass and gas, which is all that the conventional theories will allow. So if you allow electricity and magnetism to form these bodies, it can be done very quickly, and they show the forms that can be investigated in laboratory plasma discharges.
Laboratory demonstrations and numerical simulations give scientists new insights into galactic evolution.
Oh, God, this got to sting your butthole, Steve. Show me the science. I don't know. Do you consider this science, Steve? I mean, if not, then maybe that's what our problem is.
As these insights combine with spectacular images from space, a new frontier of astronomy and astrophysics is emerging.
It's time for some new ideas. The distant galaxies are much too gigantic and majestic for us to truly comprehend. Yet laboratory experiments and simulations using simple electromagnetic forces do create galactic forms without the immense time frames astronomers have proposed based on gravity. More attention needs to go to experimental displays that are not constrained by the weak force of gravity. Let those who model plasma and electricity work with the so-called Hubble sequence diagram to produce galactic structures morphing from a spiral into an elliptical, then onto an irregular galaxy by varying the inputs. This possibility is real and achievable if we'll just change the way we see the universe with more attention to the power of electricity.
he said the Big Bang has not been falsified. There's been no evidence to falsify the Big Bang, Steve said, or they would have ran it by his friend Hugh. Yeah, they would have ran it by him. Steve knows everything. They ran by him already. And then we have to, for sure, just rely on his interpretation of what's going on. Because, you know, he's Steve's astrophysicist. My goodness, Steve, you don't see the ignorance in your argument? Because it's coming straight from ignorance.
I actually changed the title a little bit. It says, was the Big Bang a fizzle? In reality, I don't think the Big Bang ever happened. So the real question is the Big Bang theory a fizzle? Modern cosmologists would have us believe that 13.75 billion years ago, a spot of infinite density and infinite temperature and infinitely small.
Imagine that. Infinite density, folks. Okay, infinite density. Imagine that. You know why you can't? Because it's an oxymoron.
Some inexplicable reason exploded in an event, now Big Bang.
Where did the infinite density come from exactly?
One way to put it is that in the beginning, there was nothing, and then nothing exploded.
There you go. So I'm so wrong that it's not even wrong, right, Steve? It's potato. But that's not wrong, because that's a great way to explain the stupidity of your Big Bang model.
Now, scientists have spent a lot of time working on this Big Bang theory, and they've taken it down to an incredible amount of detail. And here's a short extract. I'll just read this from Wikipedia. I hope you don't fall asleep on me. Approximately 1 trillionth of a trillionth of a trillionth of a second after the Big Bang happened, and we got into the expansion phase of the Big Bang, a phase transition caused a cosmic inflation during which the universe grew exponentially. After this inflation stopped, the universe consisted of quark gluon plasma, as well as all the other elementary particles. Now, I don't know about you. When I first was introduced to this theory, I was flabbergasted. Who in the world has the hubris to think that they can ascertain what happened in the first trillionth of a trillionth of a trillionth of a second of an event that occurred 13.75 billion years ago? Now, there are cosmologists that have spent their entire career lecturing on this subject, writing books about the subject, teaching their students, grading their grades, deciding whether or not they're going to advance in their careers based on whether or not they support this subject. And billions have been spent on machines to try to figure out whether the theory is correct. We built the Large Hadron Collider. We have incredible telescopes that have been put up. And we have space probes. Then they're just trying to iron out the last few minor little details about this theory. Here's a graph. Here's a graph showing part of the progression. And you can, it's kind of hard to read. But up here we start at 10 to the minus 43 seconds on up to the 10 to the minus 10th seconds. Finally, at about 300,000 years, we actually start creating atoms, complete atoms. And then we get into about 1,000 million years after this occurred, we start getting into galaxies. There's a lot of different charts and things you can find on this theory. And
and it's so dumb.
There's a wide variety of theories actually out there. But I got to say that as a person who was very interested in science and wanted to study science as a child, I was a little bit jaded by the whole thing, and I started thinking that maybe there's a better career. So I'm much different than a lot of the presenters here. Who understand relativity He answered, "Who's the third?" Now, I'm a farm boy than what Velikovsky himself wrote. The Velikovsky affair, where they talk about science not being able to accept his theory, is actually a bigger story than what Velikovsky himself wrote. In high school, I was asked to do a report on a fiction book, and I told my teacher I thought that was a waste of time. And I asked her if I could do an autobiography on Einstein instead. And she went ahead and let me do it. And there was a quote in there, and it said that when Arthur Stanley Eddington was asked how it feels to be one of the only 3 people who understand relativity, he answered, "Who's the third?" Now, I'm a farm boy from Colorado, and I read this and I thought, how in the world will I ever be able to contribute to that line of thought? So instead, I figured that maybe I should get into something a little more real. And I thought maybe designing toasters would be a lot more rewarding than studying quantum mechanics or black holes. So I got a job in the semiconductor industry as an electrical engineer, and I ended up working a lot with statistical analysis of data, trying to find patterns automatically. In semiconductors, there's a massive amount of data, and a lot of it never gets looked at. So I created programs that would try to find, and here you see in the middle, a pattern that shows up. I also got a chance to look into plasma etch equipment. And plasma is used extensively in semiconductor manufacturing to create the integrated circuits that are in our phones and our TVs and everything else. And here's an example of a plasma etch equipment. It was kind of fun. I got to change gas compositions, temperatures, RF power, and just play around with it. I spent hundreds of hours looking into these. And when I looked up and saw the Twin Jet Nebula, it became apparent to me that this is not an exploding supernova. This is a plasma formation. I now do contract work working with highly sophisticated websites that are data and media intensive. So if anyone needs something like that, just give me a call. But I very clearly remember, though, about 5 years ago when I was reading on the internet and discovered the electric universe theory. And this brought it all back to me. This brought back the joy of science and exploration. It was no longer the science of the advanced mathematics that no one else can understand. Instead, it brought it back to the science that creates this modern world. It's the electromagnetism that we know about in our motors and generators and oscillators, transmitters, receivers. All the things that have created our modern world are incorporated into the electric universe theory. It's no longer something that is only the gods of the mathematics or the high-end mathematic people that can understand. Even a mere mortal like myself could understand this. And I like to talk. I like a microphone. It's fun to get up in front of a group. So I started talking about the electric universe. And I'm as a member of Toastmasters, I had to give weekly presentations. And I started kind of branching out and doing service groups like the Rotary Group and Lions Group, and I belong to a couple spiritual groups, and they're all excited about this. And so I started giving presentations, and I kind of boiled this down. Now this will be an oversimplification, but I boiled down the 2 major ideas I see that are wrong with cosmology today into 2 concepts. And one of them is that gravity is the primary force that shapes the universe, and electricity plays no role. Now, there's a bunch of presentations on this. You're going to hear about them from other people. These are kind of some of the ideas that have fallen out of that, and I'm really not going to cover this any farther. But there's another idea which I felt never really was covered adequately in these conferences, and that's the idea that redshift can be used to measure velocity and therefore can be used to measure distance. So when you hear that a galaxy or a quasar or some object has been found that's 100 million light years away, this is the method they're using to measure that. And so some of the ideas that fall out of that is that the universe started with the Big Bang, and that's because we believe that the universe is expanding, and if it's expanding, then at some point it must have all been back together at one point. So there was a start to the universe. And it's been expanding ever since, after the Big Bang. And then they discovered that the rate of expansion appears to be increasing. And if the rate of expansion is increasing, an anti-gravity-like force is pushing the universe apart. And they called this dark energy. And then another conjecture that kind of is predicated all of this is that matter is the same across the universe. And this means that a proton weighs the same here in our galaxy as it does in another galaxy as it does anywhere else. Now, I don't know anyone that's ever sampled another galaxy and actually measured a proton in one of these other galaxies, but this is a very strong underpinning to this whole story of redshift. So you might ask, what is redshift? Well, back in 1842, a gentleman named Christian Doppler took a train, a flatbed, and put a band on it and ran it by some observers, and they would listen to it, and they all had perfect pitch, I guess, and they would listen to the change in pitch. And the idea is with sound is that when a train goes by, you hear a train go, you don't actually need the band, you can forget the band, but when a train goes by, you hear it and it goes, na 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 na, and it drops in pitch. Or another idea is a car. When you hear a car go by, it goes, phew, phew. Whereas you never hear a car go, phew. So there's a drop in pitch. And the same thing happens with light. Light is just another example of something vibrating. And up here in this first picture, if you imagine that this galaxy here is stationary and we are on the Earth looking at it, and we see an absorption line. So there's a dark spot that shows up in the spectrum. And in this case, we'll just put it in the middle because that's a good way to do this example. In this case, we have a galaxy that's moving away from us, and that effectively lengthens out this wave a little bit, and that causes the light to shift a little to the red, or a little bit slower frequency light. Likewise, if you have an object moving towards us, then it's going to shift a little bit to the blue. Now, as it turns out, almost every object we see outside of our galaxy is shifted red. There are very, very few objects that are blue shifted or moving towards us. And that's why we believe in the expanding universe. This came about with Milton Humason back in 1927, discovered that these remote galaxies were redshifted. And then Georges Lemaitre, and I probably just clobbered that, was a Belgian priest, and he actually proposed this Big Bang theory. And then finally, in 1929, Edwin Hubble, who the Hubble telescope's named after, proposed Hubble's law. And there's really two parts to the law, and that's all objects in deep space are redshifted. And that's not quite, there are a couple that are blue shifted. But then also from that, he determined that this redshift is proportional to their distance to Earth. So once again, when you hear about objects that are 100 million light years away, that is coming from this idea of redshift. Carl Sagan actually in Cosmos in chapter 10 quoted, and I had to cut out a bunch of what he wrote because Carl Sagan can really talk a lot. I'm not sure he says a lot sometimes. But the main point is that Alton Arp has found enigmatic and disturbing cases where a galaxy and a quasar that are in apparent physical association have very different redshifts. And if this is the case, if a object is, the quasars are supposed to be at the very edge of the galaxy or the universe. They're so far away, they're 12 billion light years away according to conventional cosmology. And if for some reason you can see a relationship with an alleged nearby object, then something's wrong with the whole idea of redshift. And this is actually, I should clarify, is recessional redshift, or a redshift of an object moving away from us or towards us. There are other types of redshift. There's gravitational redshift. There's thought to be, we'll get into a third one here in a second with ARP. But at the end it says ARP, if ARP is right, the exotic mechanisms proposed to explain the energy of these distant quasars would prove unnecessary. Now, these quasars are allegedly at the edge of the universe, and yet we can still see them. And if we can see them, they must be incredibly powerful. And it was brought up last night about a quasar that was thought to be 12 billion light years from us. And the web says that it's 20 billion times the size of our sun, has a mass of 20 billion times that of our sun. And there thought to be this water cloud around it of 140 trillion times that of the Earth's oceans. And it emanates the energy, I thought this was incredible, emanates the energy equivalent of 100 trillion of our suns. Now, this all comes from the idea that it's 12 billion light years away. If it happens to be much, much, much closer, then suddenly this could be just a normal object. It doesn't have to be anything this incredible. Because quasars are thought to be the most luminous, most powerful, and energetic objects known in the universe. And then this brings us to the whole point of this presentation is Halt Narp. Halt Narp went to school in Harvard and then got his PhD at Caltech. And he actually did some work for Hubble in his early career looking for novas. He worked at Mount Wilson and Mount Palomar as a staff astronomer. So he wasn't a cosmologist sitting at his supercomputer doing simulations. He actually looked through telescopes. And he created the ARP Atlas of Peculiar Galaxies, showing 333 galaxies that he thought didn't fit the model that most people believed in. He wrote several other books about redshift. And a lot of this presentation is taken from this book here, Seeing Red. So what's his evidence? And there's a lot of different evidence. I just have a couple of them up here, the main ones here. But one of the main pieces of evidence is that he has found pairs of quasars on opposite sides of nearby galaxies. And once again, the quasars are far away. The galaxies are very close. How is it that these quasars could be related to this close by galaxy? Here's an example. This is IC 1767. It's called a Seifert galaxy. A Seifert galaxy is known to emit lots of X-rays and radio waves. And they found these two quasars right next to it. Now, what's odd about this is that these numbers here, this 0.616 and 0.669, are indicators of the redshift. And if it's a positive number, that means that it's redshifted, is moving away from us. If it's a negative number, it's blue shifted and moving towards us. And these two redshifts are extremely close. And the probability of finding two quasars opposite a central galaxy with an extremely close redshift is very, very low. And I don't remember the exact numbers on this, but I know he quotes numbers 1 in 10,000, 1 in 100,000 for some of these different examples.
But, oh my goodness. So, anyway, one of his book, there's 330 something examples. And yeah, so yeah, Mr. Big Bang.
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. Since the early 20th century, the story of our universe's origins has been a shifting and incredibly strange tale. Today, it's generally accepted that the person who originated the now widely held Big Bang Theory was a Belgian priest named Georges Lemaitre, who proposed in the 1920s that the universe's primordial creation began with a single atom. Around 1980, the physicist Alan Guth developed the idea of cosmic inflation, or the notion that physical space experienced an exponential expansion immediately after the Big Bang. On this series, we have reported on countless discoveries that in effect falsify the foundations of the Big Bang Theory. Nevertheless, it remains the dominant view in 21st century cosmology. In this episode, Thunderbolt's Picture of the Day managing editor Stephen Smith offers his analysis of the current state of Big Bang cosmology, and specifically, the evidence for and against cosmic inflation.
Cosmology today is dominated by the Big Bang Theory. The theory's major premise is that there was once a void containing no matter, no space, and no time. For some unknown reason, a burst of energy from another realm of existence replaced the void with the present universe. The Big Bang Theory was developed because the astronomer Edwin Hubble believed that he observed remote galaxies receding from the Milky Way. The most surprising thing was not recession itself, but the high velocities associated with his measurements. According to his calculations, some galaxies were traveling away from his observatory at thousands of kilometers per second. Hubble arrived at his conclusion because of what was later called the redshift of light frequencies. Adopting the Doppler effect to the spectra of various galaxies, Hubble thought that the change in location of particular elemental signatures called Fraunhofer lines indicated that light waves were shifted toward the red end of the spectrum by a recessional velocity. Fraunhofer lines are supposed to occur at specific frequencies in the spectrum by whatever element is absorbing light. If they are in a different location, then they have been Doppler shifted because of the element's acceleration. This forms the backbone of galactic scale distance calculations, along with the recession that galaxies display. Using this system of redshift, some galaxies are thought to be moving at an unbelievable 90% of the speed of light. All that we see and experience is supposed to have been born in the Big Bang explosion, so the original inertia imparted to the universe came from that event. Since distances and relational velocities are correlated with a time scale, something like a galaxy or a quasi-stellar object that is 10 billion light years away is also thought to be as it was 10 billion years ago. Astronomers think that they see ancient light traveling through space for 10 billion years. The current estimate for the age of the universe is 13.7 billion years, and as mentioned, distance and time are thought to be related to each other because of redshift. So when we look out at the universe, distance provides information that determines how old it is. In other words, the diameter of the observable universe should be approximately 27.4 billion light years. However, there's a problem associated with that figure. According to astrophysicists, the universe is thought to be 156 billion light years in diameter and not 27.4 billion. What explains that anomaly? The answer is supposed to be something called inflation. Astrophysicists in the past were shocked when observations seemed to show more complexity in the early universe than should exist. As the principle of inflation states, though, it's not merely the acceleration from the Big Bang that is affecting the spectra of remote galaxies, but it's that the space in which they are embedded is expanding. If it requires X amount of time for a galaxy to form, and the universe is Y years old, then a galaxy should not exist at time distances less than Y minus X. When such galaxies were seen, some other explanation had to be added to the Big Bang to account for them. So objects that appear to be redshifted to extreme distances may not be as old as their spectra suggest. They're moving along with the expansion of space. As inflationary theory proposes, they're not as old as they appear to be because they're simply farther away. That dichotomy seems to demand that the early universe was expanding faster than the speed of light, since its size is more than 11 times greater than its age. Edwin Hubble's observations of galactic distances versus speed of recession led to another quandary. Galaxies that are far enough away move so fast that they must exceed the speed of light. That's known as the universal horizon or the Hubble radius. It's a point beyond which instruments can never see because light from over that horizon can never catch up to the expansion velocity of space. The theory of special relativity doesn't allow any object to reach the speed of light, let alone exceed it. So how do space scientists deal with that dilemma? They do so by ignoring the restrictions of special relativity and resorting instead to general relativity, where such restrictions don't exist. Since no information can be transmitted from beyond the Hubble radius, no violation of relativity occurs. Just how did these twists and turns in ideas, as well as the warping of time and space, come about? They're a direct result of the assumption that redshift correlates with distance. Modern cosmological systems are built without exception on that assumption. But what if Hubble's original premise was flawed? What if redshift is really a red herring? Where can we turn for an explanation? Well, we can look at the work of Halton Arp, an astronomer whose reputation was at least the equal of Edwin Hubble's. In the 1960s, astronomers discovered quasi-stellar objects, better known as quasars. They have large redshifts, implying that they're located near the farthest edge of the observable universe. Quasars are referred to as quasi-stellar because they're relatively small, little more than a light year in diameter, yet they emit a lot of energy. So they're thought to be the most powerful continuously radiant objects in the universe. The only other active energy sources detectable at those vast distances are gamma ray bursters. However, GRBs last for minutes, whereas quasars shine continuously. They remain as bright as when they were first discovered. Some astronomers found that many quasars are associated with spiral galaxies and appear to be near the galaxy instead of billions of light years distant. Based on other ideas, such as quasars' anomalous apparent brightness when compared to their redshifts, Hubble's expanding universe theory was called into question. Long before the quasar problem arose, though, Hubble himself suggested that inflation might not have taken place in the early universe. He thought that new observational data was necessary in order to decide whether it was definitive. In 1947, he was waiting for the new 200-inch telescope at Mount Palomar to be built. So in Publications of the Astronomical Society of the Pacific, Volume 59, number 349, he wrote, "It seems likely that redshift may not be due to an expanding universe, and much of the speculations on the structure of the universe may require re-examination. We may predict with confidence that the 200-inch will tell us whether the redshifts must be attributed as evidence of a rapidly expanding universe or attributed to some new principle of nature," unquote. Unfortunately, nothing definitive resulted from astronomers working with the Hale telescope or the many spaceborne telescopes that have been launched since then. Instead, redshift and inflation are a dogma among the astronomical community, and ever more arcane mathematical excursions have been added to the mix. Although many observations contradict the consensus view and have been doing so for 50 years or more, those data are ignored or marginalized. High redshift quasars, as previously mentioned, are found in axial alignment with galaxies that possess substantially lower redshift. They're also sometimes connected to lower redshift galaxies by bridges of luminous material. Halton Arp was the lone voice among a crowd of scientists when he started publishing papers that demonstrated inflation or the Big Bang theory were not valid. As Hubble predicted, Arp's research using the 200-inch Hale telescope demonstrated, quote, "some new principle of nature," unquote. One of Harp's more interesting images was NGC 4319 and its companion quasar Markarian 205. Arp called attention to the fact that the lower redshift galaxy is physically connected to the higher redshift quasar. A filament between the two objects violates the measured distances because no such connection should be possible. After all, NGC 4319 is said to be about 600 million light years from Earth, while Markarian 205 is around 1 billion light years away. If those objects physically connected, they must be near each other and at the same distance. Their redshifts have to be from some other factor not related to distance. There must be something intrinsic to their makeup. Arp assembled a catalog of discordant redshift association that describes anomalous structures or physical links among objects with radically different redshifts. Some of the observations show quasar pairs being ejected in opposite directions from active galaxies. This led to the so-called ejection model of galaxy formation. In brief, high redshift quasars around galaxies are the daughters of the mature galaxy. Their various redshifts do not indicate distance, but age. Arp speculated that redshift measurements of quasars is not composed of a velocity value alone, but also depends on the aforementioned intrinsic redshift. Intrinsic redshift is a property of matter, like mass or charge, and can change over time. According to his theory, when quasars are ejected from a parent galaxy, they possess a very high intrinsic redshift, z equals 2 or greater. As the quasars move away from their origin within the galactic nucleus, their redshift properties begin to decrease until they reach somewhere near z equals 0.3. At that point, the quasar resembles a small galaxy. The inertial moment of ejection is eventually overcome, and the mass of the quasar increases while the speed of ejection decreases until it may become a companion galaxy. That is how galaxies form and age, according to Arp, evolving from highly redshifted quasars to small irregular galaxies and then into larger barred spirals. There are several other examples of fast-moving quasars in front of slower-moving galaxies or connected to them with luminous filaments. NGC 7603 is a distorted spiral galaxy with a single arm, joined by that arm to a smaller companion with a much higher redshift. And also within the bright material of the arm are two other objects, each with redshifts different from the galaxy pair. There's nothing conclusive in the mainstream scientific journals about ARP's data. His revelations concerning problems with consensus dogma were considered too intolerable, so he was censured by his peers. However, the evidence he gathered and promoted ought to make us stop and think. Is the Big Bang dead? How big and how old is the universe if redshift readings are not reliable indicators of distance? This discussion could almost be completed with one statement. A theory built on questionable assumptions should never be the basis for new theories. Astronomers think they found proof for the inflationary Big Bang theory in observations of the so-called cosmic microwave background. The CMB is said to be the remnant signal left over from the beginning of the universe. In the early 1960s, Arno Penzias and Robert Wilson began to use the Holmdel satellite antenna as a research tool. The antenna was originally built to detect signals bounced off the earliest satellite communication system known as ECHO. The ECHO satellite was an aluminized mylar balloon, 30 meters in diameter. Radio signals beamed from Earth were reflected by the satellite, allowing transcontinental wave broadcasts for the first time without relying on what was quickly becoming a saturated network of transoceanic cables. Penzias and Wilson's original plan was to use the horn to amplify radio signals from the Milky Way as well as from the space between galaxies. They were attempting to create some of the first radio maps of deep space, and they got their chance after the Telstar satellite launch made ECHO obsolete. They soon discovered the antenna was picking up a lot of noise, so much so it was making it difficult for them to carry on with their projects. That story is probably familiar to a lot of people by now. They checked the antenna by pointing it at New York City to see if that was the source of the interference. Then they looked to see if it was some kind of radiation from the galaxy, or perhaps from a above ground nuclear test, or maybe it was distortion from a nest of pigeons living in the horn. After a full year of trying to locate the source and finding that it was uniform across the sky, they concluded that it had to be coming from somewhere so distant that it was fundamental to the overall structure of the universe itself. In 1964, Dr. Robert Dick of Princeton University, building on George Gamoff's 1948 theory about the creation of heavy elements in what is now known as the Big Bang, proposed that there ought to be a 3 Kelvin glow left behind by the original creatio ex nihilo event. However, before they could complete their own radio antenna, Penzias and Wilson announced their findings, earning them the Nobel Prize. Robert Dick remained heavily involved with the Big Bang theory until his death in 1997. Dr. Alan Guth attended a lecture by Dick in which he, Dick, explained the problems with the Big Bang theory at that time. One of those problems involved the question of density in the universe. If the universe contains insufficient mass, it will continue to expand until all the stars go out and all the matter loses its motion. This idea was called heat death. If there's a greater density, then the universe will draw back in on itself due to the force of gravity into what is called the Big Crunch. Guth decided to tackle the problem since many other considerations too numerous for detailed explanation here began to emerge. One important discussion centered on why the universe appears so uniform. It looks pretty much the same no matter where instruments are pointed. His solution for the observed homogeneity of the universe in general and of the CMB in particular was a period of inflation. In August 1980, he published The Inflationary Universe, a possible solution to the horizon and flatness problems. Today, inflation is one of the foundational principles in Big Bang theory because it, quote unquote, solves the homogeneity problem. Suffice to say, space is not a substance any more than time is. Space cannot warp or bend or ripple or expand. Space is defined as the unlimited or incalculably great three-dimensional realm or expanse in which all material objects are located and in which all events occur. It's a domain without substance, since it's where substance exists. It is not that substance. Therefore, it has no existence except as a method for defining the existence and position of things. To infer that space and time are a fabric in which gravity can wave is ludicrous. It's tantamount to saying that space exists in and of itself and is capable of alteration. In conclusion to this brief discussion, it appears that science is building castles in the air. Eventually, they're all doomed to fall. In the electric universe, conclusions are never based on the reification of abstractions. Instead, observations point to the electrical nature of the cosmos without the need for an endless series of ad hoc concepts designed to prop up sagging theories.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info. Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. Scientists working with the BICEP 2 telescope are claiming to have discovered the so-called first direct evidence of cosmic inflation, a process of radical expansion believed to have occurred after the theoretical Big Bang explosion. Based on data from the cosmic microwave background, the team also claims to have directly confirmed the existence of gravitational waves. ScienceDaily.com reports on these findings. Gravitational waves squeeze space as they travel, and this squeezing produces a distinct pattern in the cosmic microwave background. However, as is so often the case with science press releases, absent is the distinction between fact and theoretical interpretation.
The headline of Science Daily for the 18th of March says, "Tremors of the Big Bang, first direct evidence of cosmic inflation." It goes on to say, almost 14 billion years ago, the universe we inhabit burst into existence in an extraordinary event that initiated the Big Bang. In the first fleeting fraction of a second, the universe expanded exponentially, stretching far beyond the view of our best telescopes. It then says, all of this, of course, was just theory. However, the way I read it, and also the way it's presented on the media, you would not know that it was a theory. The Big Bang is the real story of how the universe was formed. The Big Bang theory, however, is a theory which relies on miracles. The initial creation event is a miracle because physics doesn't deal with the creation of matter. Metaphysics does, and this is not metaphysics we're talking about here. This is supposed to be fact. The other thing is that observations have been chosen to fit the theory, and the theory is infinitely malleable. It doesn't matter almost what you find. You can dream up some particle, some energy, anything you like to make the theory continue in its original form. The article goes on to say, researchers from the BICEP 2 collaboration today announced the first direct evidence for this cosmic inflation. Their data also represent the first images of gravitational waves or ripples in space-time. These waves have been described as the first tremors of the Big Bang. Finally, the data confirm a deep connection between quantum mechanics and general relativity. This last statement is actually false because neither quantum mechanics is understood nor is the nature of gravity. General relativity never explained it. It was merely a mathematical contrivance to describe the observed effects of gravity. And quantum mechanics, as even Richard Feynman pointed out, anyone who thinks they understand that doesn't understand quantum mechanics. And the reason for all of this is that Einstein himself prevented any chance of a reconciling of quantum mechanics and gravity, because he introduced the speed of light as a barrier to the transfer of information. No information could be transferred faster than the speed of light. And yet quantum experiments show that particles can be so-called entangled at great distances, and if you flip one, the other one instantly flips in response to maintain conservation laws. This shows that there is a connection which travels far faster than the speed of light at the subatomic level. Similarly with gravity, the Earth orbits where the sun is at this instant, not where it appears in the sky, which is 8.5 minutes later, the time taken for light to travel from the sun to the Earth. Einstein, by setting the speed limit for light and the transfer of information, effectively closed off any chance of understanding quantum effects at the subatomic level and gravity at the level of the solar system and galaxies. So for these scientists to say that the data confirm a deep connection between quantum mechanics and general relativity is false, because neither of them are understood. The electric universe has a much simpler picture, and that is that all matter in the universe is connected in a sense in real time by a direct electric force. This also means that there is no such thing as a gravitational wave, or that there can be ripples in space-time. The very concept of space-time is nonsensical, because space is merely the relationship between objects in 3 dimensions. It has no substance. It cannot be bent or twisted or rippled. And the same thing with time. Einstein, with his thought experiments, which are an oxymoron, you either do an experiment or you don't. If you think about it, it's purely imaginary. In a sense, Einstein made things which we see or imagine we see real. It's like watching somebody disappear in the distance at the rear of a ship or a train or something like that. And as they disappear in the distance, they shrink in size. And if we could hear their watch ticking, it would tick more slowly. We know that that's not the case. Their space is not shrinking and their watch is not ticking at a different rate to ours. But Einstein said these were real effects, and in doing so, he destroyed any chance of modern physics matching reality. Gravity has no effect on light either, as Edward Dowdy Jr. showed at the Electric Universe conference last month. Light passing by a star is bent according to the normal rules of diffraction in an atmosphere. Just as we see the sun after it's set for a short time, it's because the atmosphere is bending the light. It's not because of the gravity of the Earth. It's not because of the gravity of a star that starlight in the background is bent around a star. In fact, if it were so that gravity had an effect on light passing by a star, as predicted by Einstein, the effect would be much more long range, and we should see gravitational rings around stars as a very common event in the sky. We do not see such things. So-called gravitational lensing of distant galaxies was shown by Helton Art to be actually plasma structures ejected by a central object, a central galaxy. So gravitational lensing is a false idea. The whole thrust of these articles about the ripples in space-time and ripples from the Big Bang are based on the idea that the cosmic microwave background radiation is a result of the Big Bang explosion. But the electric universe has pointed out for many years now that it's a pure assumption that this faint signal, which is way down amongst the noise, is actually anything to do with a background radiation. If it were a background radiation, you would expect that foreground objects would shadow that background radiation, and we don't observe that. The electric universe says that the radiation is actually foreground radio waves from the electric currents that flow through the galaxy in the form of twisted Birkeland currents. And it's significant that this discovery is of apparent twisting of the magnetic field, which is evident in the signal that's received. It's said the swirly B mode pattern is a unique signature of gravitational waves because of their handedness. However, Birkeland currents also have polarized signals and handedness. And since they're very close, you would expect that the signals or the rotation pattern is large, and this is what's been discovered. Also, the signal is much stronger than expected. They said rather than finding a needle in a haystack, it was like finding a crowbar. Well, that should have been an indication that the theory that they were applying was incorrect. I would predict that if it were possible to aim radio telescopes at the same region of the sky, and this may be difficult at the South Pole, that the magnetic pattern in the 21 centimetre hydrogen band would show the same kind of pattern. That is, if the pattern is real, because, as I said, the signal is extremely small. It's so disappointing to see articles which just state baldly an image was seen in the cosmic microwave background, the glow that radiated from that white-hot plasma, and that over billions of years of cosmic expansion has cooled to microwave energies. Halton Arp has shown that redshift, which is supposed to be due to the expansion of the universe, is due instead to the intrinsic nature of the matter in a quasar, or whatever it is that's being observed, that has such a redshift. And he showed that the redshift is a measure of the youthfulness of an object and not its distance. So all of the talk about inflation and expansion and accelerated expansion is based on incorrect interpretation of the data. Halton Arp's work was said to have been discredited, but it was done by using statistical techniques which ensured that his effect would not be seen. So Halton Arp's work still requires scientists to go back and look at his evidence in his way.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info. Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. For many years, astronomers have expressed confidence in their understanding of the origins of the universe. Today, most astronomers agree that a primordial creation event called the Big Bang gave birth to the universe precisely 13.7 billion years ago. But a new scientific study is one of many findings that raise significant questions about this theory. Researchers using the Hubble telescope have spotted an astounding spiral galaxy. Astounding, they say, because it shouldn't exist. The researchers have dated the galaxy's age at 10.7 billion years old. Lead author of the study, David Law, says of these findings, "The fact that this galaxy exists is astounding. Current wisdom holds that such grand design spiral galaxies simply didn't exist at such an early time in the history of the universe." What are we to make of these and other findings that defy the underpinnings of the Big Bang theory?
Standard theories dictate the faster an object recedes from Earth, the farther away it is, because the primordial Big Bang explosion is supposed to have imparted an initial push that's causing the universe to expand. Using those theoretical parameters, a faster recessional velocity means greater distance, which means an earlier time period in the universe. And since an object almost 11 billion light years away is from the so-called early days of the universe, it shouldn't exhibit such complexity of form because there wasn't enough time since the Big Bang for that complexity to evolve.
Astronomers are surprised to find a high redshift galaxy with spiral structure. It has a redshift of 2.18, and most galaxies with that high of a redshift have irregular shapes. This one has well-defined arms, and it even has a companion at the end of one of them. The Big Bang theory assumes that redshift is an indicator of distance, which would put this galaxy at about 11 billion light years away. If it's that far away, it's therefore large and bright. But modern astronomy dismissed the observations of many astronomers in the last half of the 20th century, astronomers like Halton Arp and the Burbages. They found that high redshift objects tend to cluster around nearby low redshift objects. They found many physical connections, and they even found some high redshift objects in front of low redshift objects. These observations were misrepresented, and the misrepresentations were disproved. So with that excuse, the observations were dismissed and the Big Bang theory was saved. This is kind of a new scientific method. Instead of observation, theory, and testing, the data is judged by its conformity with belief. If it doesn't conform, then there's something wrong with the data, and the data is dismissed. In this case, fervency of belief replaces testing. If redshift is not proportional to distance, then the universe is not expanding, and there's no Big Bang.
Scientists in the electric universe community suspect that high redshift is intrinsic to the plasma environment of a young or newborn galaxy.
This galaxy is likely nearby, small, and faint. In the electric universe hypothesis, high redshift is an indicator of youth and being highly charged. High redshift objects are born by electrical injection from older galaxies. So the companion at the end of the arm indicates that this galaxy has had recent ejection activity. It's an active galaxy, and active galaxies are usually spiral. So in the electric universe hypothesis, this object isn't surprising at all. It's expected.
The same electric force responsible for a galaxy's redshift may also give rise to its spiraling structure and other features such as polar jets.
One of the most significant contributors, I would say, to plasma cosmology and the electric universe theory was Dr. Anthony Peratt, a plasma physicist. And he was a protege of Hans Alfvén, the famous Nobel laureate. And Peratt studied plasma formations in the laboratory for many years. And what he did was create what are called particle and cell animations on supercomputers. Galaxies are, rather than being condensations of gas and dust that are gravitationally bound together, were actually plasma formations. And he thought that these simulations showed that cosmic plasma is confined due to self-consistent magnetic fields. And these magnetic fields are induced by currents that are flowing through the plasma, creating filamentary structures. And a cross-section through these filamentary structures indicated the formation of several galaxy configurations. And among those configurations were elliptical and barred spiral shapes. So Peratt insisted that plasma, along with electricity, engenders the structures in the universe. And since galaxies are often strung like pearls through space, or like beads on a string, that galactic arrangement lends credence to that idea.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info. Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. For many decades, the standard cosmological model has stated that the universe began many billions of years ago with a primordial explosion called the Big Bang. Beginning from an unimaginably hot, dense point, material rushed outward at nearly the speed of light. And to this day, the physical expansion of the universe is thought to continue. When scientists found evidence for the apparent acceleration of the expansion rate of the universe, the hypothetical influence of dark energy was invented. For a scientific hypothesis to be testable, it must make predictions. And the technological data available to test the Big Bang hypothesis has never been final. For over 5 years on this series, we have reported on numerous theory-shattering discoveries that challenge the very underpinnings of the Big Bang. From impossibly huge structures that exceed the size limits for any object at this time in the Big Bang universe, to so-called ancient stars whose chemical composition is completely wrong if they formed from material in the early universe, to grand design galaxies that display a complexity of form that defy their theoretical age, to evidence that the so-called expansion of the universe is accelerating at an impossibly fast rate, even accounting for dark energy's influence. Many scientists have acknowledged the major problems these discoveries pose for Big Bang cosmology. Nevertheless, consensus scientific opinion remains that the Big Bang is the best current theory for the origins of our universe. Indeed, a recent Scientific American article aroused a response from some of the world's most revered cosmologists that demonstrates just how slow and difficult is real change in the culture of science. The article in question, entitled "Cosmic Inflation Theory Faces Challenges," proposed that the universe began with a so-called Big Bounce instead of a Big Bang. The authors question cosmologists' interpretations of measurements of the so-called cosmic microwave background. Specifically, they disagree with the interpretation that data first published in 2013 proves that an extremely fast inflation occurred after a Big Bang 13.7 billion years ago. They state, if anything, the Planck data disfavored the simplest inflation models and exacerbated long-standing foundational problems with the theory, providing new reasons to consider competing ideas about the origin and evolution of the universe. Yet even now, the cosmology community has not taken a cold, honest look at the Big Bang inflationary theory, or paid significant attention to critics who question whether inflation happened. In a response letter to the controversial article, 33 scientists, including physicist Stephen Hawking, begin with a statement: "There is no disputing the fact that inflation has become the dominant paradigm in cosmology." They then accuse the authors of, quote, dismissing the research of not only all the authors of this letter, but also that of a substantial contingent of the scientific community. However, the problems for Big Bang cosmology reach far beyond anything that Hawking and his colleagues seem ready to acknowledge. On the question of the so-called cosmic microwave background, or CMB, the conclusion that the radiation is a, quote, background at all begins with the assumption of a Big Bang. But as previously discussed on this series, ample evidence exists to consider that the, quote, asymmetric radiation is in fact a locally produced foreground. As physicist Wal Thornhill has explained, proponents of the electric universe and plasma cosmology argue that the radiation is due to microwave radiation from the filamentary galactic electric currents flowing in the neighborhood of the sun. In fact, some of the expected structures, a galaxy-wide sample of dense filamentary structures correlated with spiral arms and star formation, have been recently mapped. The image on your screen is an example of a network of galactic filaments. As Thornhill notes, we see a roughly orthogonal branching of tributaries, which is characteristic of an electrical discharge. This principle is seen in this comparison with experimental discharge filaments. If the CMB is in fact what physicist Eric Lerner has described as a, quote, radio fog of dense plasma filaments, its presence tells us nothing about the age of the universe. The local origins of the radiation would also help explain the seemingly baffling discovery of apparently vast and remote cosmic voids. The appearance of a cold spot, where the, quote, temperature of an area of space is interpreted as significantly lower than the surrounding region, suggests the presence of a void where many galaxies should be observed. The interpretation of the size of the so-called void is based on the assumption that the redshift of the surrounding galaxies provides an accurate measure of the object's size and distance. In recent years, some scientists have offered the incredible speculation that such a void is actually the imprint of a parallel universe. In fact, the concept of parallel universes, or the multiverse, is a theory championed by the aforementioned Stephen Hawking, as well as Brian Greene, Michio Kaku, and the current host of the television show Cosmos, Neil deGrasse Tyson. Ironically, at the time that cosmologist Carl Sagan wrote his iconic book, Cosmos, challenges to the very foundations of the Big Bang were still permitted. On the question of whether the Doppler interpretation of galactic redshift is a reliable indicator of an expanding universe, Sagan wrote, "There is nevertheless a nagging suspicion among some astronomers that all may not be right with the deduction from the redshift of galaxies via the Doppler effect that the universe is expanding. The astronomer Halton Arp has found enigmatic and disturbing cases where a galaxy and a quasar, or a pair of galaxies that are in apparent physical association, have very different redshifts." Sagan continues, "If Arp is right, the exotic mechanisms proposed to explain the energy source of distant quasars, supernova chain reactions, supermassive black holes, and the like, would prove unnecessary. Quasars need not then be very distant, but some other exotic mechanism will be required to explain the redshift. In either case, something very strange is going on in the depths of space. At the other end of the spectrum from so-called vast cosmic voids are objects that appear impossibly huge. One such object, the quasar cluster Huge LQG, is supposedly so enormous it would comprise about 5% of the visible universe. As one astronomer said of the discovery, it, quote, upsets the foundation of everything we do. The force of gravity is weak and takes time to move things around. The elapsed time since the conjectured Big Bang sets a limit on how big any structure can be. Structures exceeding that limit are, by the cosmologists' own admission, impossible. One possible solution to this enigma is that the objects simply are not as distant and huge as they appear, based on their measured redshift. Halt and Arp proposed that the redshift of quasars depends not only on a velocity value, but also its, quote, intrinsic redshift. This would be a property of matter that is subject to change over time. Arp found that the intrinsic redshift of a quasar or galaxy took discrete values, which decreased with distance from a central active galaxy. In Arp's hypothesis, many mature galaxies of a specific type eject newborn objects, called QSOs, or quasars, and these objects grow up to be companion galaxies of their parents. As they move away from the parent, their mass and brilliance changes, their velocity slows, and they tend to begin to fall back toward the parent galaxy. Proponents of the electric universe, including physicist and chief science advisor to the Thunderbolts project, Wal Thornhill, agree with Arp's thesis of quasar ejection. However, Thornhill disagrees with Arp's description of the mass of quasars increasing with time. Arp proposed that the existence of a new quasar becomes recognized by matter in the rest of the universe at the speed of light. But in Thornhill's view, an initially positively charged quasar is followed by a beam of electrons from its parent galaxy, which would explain both a quantized redshift and increase in mass. These electrons may come in bursts, like the quasar ejections themselves, which, if true, would predict and explain seemingly impossibly sudden changes in quasars. As we reported last year in this series, many recently discovered objects in space lend great credence to this thesis. A team of astronomers using the Sloan Digital Sky Survey observed quasars behaving in a manner that completely upends conventional theory. Using images from the Pan-STARRS survey, the scientists identified 1,000 objects that appeared to vary in brightness over a period of just 10 years. Among these objects were a total of 5 galaxies that the team witnessed shape-shifting into quasars in a seemingly impossibly short period of time. The team also recorded a total of 12 quasars, quote, shutting down in a period of hundreds of days, rather than the hundreds of thousands of years required by standard theory. As reported by newscientist.com, astronomers expect quasars to use up their fuel and settle down into quiet galaxies, a process that should take hundreds of thousands of years. So last year, when 12 quasars were spotted shutting down in just hundreds of days, it was a shock. In subsequent decades, as demonstrated by the recent protests of Hawking and company, little has changed in the culture of science. The seemingly endless cosmic surprises have yet to force any real reassessment of the cherished 13.5 billion year, quote, history of the universe. Institutional science remains unready to confront the possibility that based on our current limited knowledge, we must accept a universe of unknown age and extent. So the surprises for cosmologists will only continue, since nature seems to have no regard for human beliefs. For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info. Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. A team of astronomers is claiming to have observed an object whose existence shatters the underpinnings of the Big Bang Theory. The quasar group, called Huge LQG, is supposedly so enormous it would comprise roughly 5% of the observable universe. By conventional reasoning, an object of this size simply cannot have formed since the theoretical Big Bang explosion. According to lead author Dr. Roger Close, the finding upsets the foundation of everything we do. But as is so often the case with baffling space discoveries, are we being told the complete story?
The question that arises from this recent finding of a gigantic quasar cluster, which, according to the headline, shatters long-held theories of space, is that it actually shatters the long-held theory of the Big Bang. But that's not specified. It's just put in general terms because, of course, there is no alternative to the Big Bang Theory at present, or at least there isn't according to conventional science. Of course, the Electric Universe sees all of this as being confirmation of Helton Arp's work of decades ago, where he actually predicted that these highly redshifted objects, the quasars, would appear to be larger and larger and brighter the higher the redshift, simply because of this idea that the redshift is a measure of the distance. Now, Helton Arp has shown, and the Electric Universe actually expects, that quasars are merely faint because they're young. They've just been recently hatched, so to speak, from a parent galaxy, and they're highly redshifted. But they are born from nearby galaxies, so these things are much closer than the 9 billion light years that is specified in the article.
This large quasar group, they call it the Huge Quasar Group. It's almost 9 billion light years away. That's if the distance is proportional to redshift assumption that they make is true. It's 4 billion light years long. The press release says it would take 4 billion years to cross it, which makes it sound like it's more or less spherical. But actually, it's only 1 billion light years wide. It's actually a filament. The paper that reports on it says discreetly that it's substantially elongated. That's quite a bit elongated. It covers 20 degrees of the sky. You could put 40 full moons side by side along the length of it. Of course, it's thin. It's not anywhere near spherical. The sizes come from the assumption that the distance is proportional to its redshift. Its redshift is 1.27, and the magnitudes of the quasars in it range from 18 to 19. There could be some fainter ones because the survey arbitrarily cut off at 19. It lies 25 degrees west of the Virgo cluster, and the magnitude range of the objects in it are similar to the Z=1 quasars that Helton Arp is associated with the Virgo cluster. It overlies 3 Messier galaxies, the M95, M96, and M105, which are a little bit closer than the Virgo cluster, according to the standard reckoning. So it's kind of on the fringes of the Virgo cluster. And my first guess is that these quasars are actually ejections from these Messier galaxies at the edge of Virgo. So if they're at the conventional distance of the Virgo cluster, then this huge group is only 20 million light years long instead of 4 billion. It's 200 times closer than what they think it is, and it's only 0.5% as big as they think it is. The result of the distances proportional to redshift assumption is that astronomers are looking at gnats swarming around their heads and thinking that they see fleets of 747s on the horizon. The observational evidence that undermines the distance is proportional to redshift assumption has been known since the 1980s from the work of Paul Nart, who noticed that these high redshift quasars had a statistical and oftentimes a physical association with nearby active galaxies. Standard astronomers have ignored this evidence, and they've backed themselves into not just a corner, but a very long dead end. If redshift is not primarily a measure of distance, then the expanding universe and the Big Bang cosmology are obsolete.
The astronomers' observations of huge LQG also challenge the cosmological principle, which theorizes that the universe is homogeneous or the same in all directions.
The cosmological principle actually goes back to Newton. It's the assumption, again, there's that assumption, that we don't occupy a unique place in the universe, that at sufficiently large scales, the universe will look the same from every point within it. So if this holds up, this would mean that at the largest scale, the universe is not homogeneous, that this clump of matter couldn't have developed from gravity since the Big Bang.
Notably absent from media coverage of huge LQG is any meaningful discussion of the predictive success of the astronomer Halton Arp.
It really is scandalous that Halton Arp, a noted astronomer of his day, who predicted that this kind of observation would be made, is not even mentioned in the article. And in fact, I've seen no comment anywhere in the news items at all about Halton Arp's work, which predicted this kind of finding. You would expect that a finding which goes against what is generally believed and something that is predicted would be headline news, and that Halton Arp should be singled out for recognition. Instead of that, we see nothing, silence, and there's waffling about long-held theories of space without saying that the Big Bang Theory has actually been disproven.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.
He's expert at image acquisition and analysis. We've talked a lot about common sense, and common sense is essential to having keeping our feet on the ground and forming cogent understandings of the world that we live in. But we know also that our senses are somewhat limited. There's only so much that we can see with the eyes that we've grown in our bodies, that we can touch with our hands and our five senses. So science, when it's properly functioning and serving common sense, extends those senses into the realms beyond our ability to perceive, to, in a sense, make visible that which is there, but is invisible to our common senses. And that is part of the expertise of our next speaker. An important part of what Pierre-Marie Robitaille has accomplished at. In 1996, he was responsible for developing, breaking essentially the world record for magnetic resonance imagery, developing, essentially doubling the power of magnetic resonance with an 8 Tesla MRI. And I believe he's going to share with us some of what he sees to add to our growing sense of the electric universe. Welcome, Professor Pierre-Marie Robitaille.
Well, thank you. I would like to begin by thanking Dave Talbot for inviting me here and for providing scientists from different viewpoints the opportunity to address the scientific community. It is a privilege to be here. Today I'll be speaking about the microwave background. And as Steve tried to explain to you, When you look at the microwave background, if you're located on the Earth, you have signal from the Earth itself, the emissions of the oceans, water around the Earth, and then you also have galactic emissions that are reaching the Earth. You have signals beyond the galaxy, perhaps, that we get to see as well. So there are many signals that are coming when you're at the Earth, but when you're at L2, the Earth, of course, cannot hit the satellites that are at L2. Therefore, you will not get a monopole at L2. And the only data, if you want to call it data, that you get at L2 will be dominated by the galaxy. Before I begin to speak, because I'm in the College of Medicine, I did want to speak just briefly about anchoring. Now, in medicine, what is anchoring? Anchoring occurs when a patient comes to the hospital and he's gravely ill. And we'll assume that he's gravely ill. And what happens is that a physician sees him and he decides on the diagnosis. But the diagnosis is incorrect. The next physician comes and sees him and doesn't do his own physical and follows the diagnosis of the first physician. So eventually, unfortunately, our patient dies. The doctors get sued. They lose their license. And of course, the attorneys get to make lots of money. But what happens in physics when we anchor? Well, that's a different problem because we're not in a position that somebody's going to lose their life over it. At least we hope not. But when physics makes an error, it's much harder to rectify because you can anchor and it takes tremendous incentive to go back and recheck the assumptions. So relative to the microwave background, to recheck the assumptions, you actually have to go all the way back to 1860 and deal with Kirchhoff's law of thermal emission. Now, I will talk about that law on Sunday, not now, because it in of itself is actually the most important talk I will give, even though this one's on the background and the other one is on the sun. Also, because I'm in the College of Medicine, let's see now, I have to figure out how this works. I'd like to dedicate this work to two physicians. Now, the first is my father. He just retired from medicine after more than 50 years, I think 55 years as a physician. He was a family practitioner. He delivered over 800 babies in his life. He also helped the Sagamok Indians in Northern Ontario. And he lowered the infant mortality rate for the Sagamok First Nations, both for the mothers and their babies. He was one of the first Caucasian men to be named as an honorary Indian chief in North America. The next, whoops, that's the mistake that we make. Okay, I'll get it here. The next person that I'd like to dedicate the talk to is Dr. Ignaz Semmelweis. Now, I dedicate it to him as well because he's got a lesson for us, right? So in 1847, he advocated that physicians wash their hands with chlorinated lime solutions to reduce the incidence of mortality from childbed fever. And physicians saw this as an insult because they felt that, you know, they were already pretty clean, even though they were going from the necropsy lab to delivering women. And they were killing these mothers. And he actually documented when he got the doctors to wash their hands that the mortality rates would drop. So the physicians, rather than just listen to him and keep washing their hands, decided that he had to be incorrect. His papers and ideas were largely rejected. There were only a few people of the European medical community that recognized the importance of what he was saying. He's actually, I think, the father of hygienic methods. And he unfortunately died in an insane asylum. He was only 47. Now, I've published extensively on the microwave background, and I list the papers here. Some of the important ones relative to the talks of Steve and I are a WMAP, or radiological analysis, of course, the papers on the Earth contribution, the paper on water, the bottom one that's listed there. Then you also have this all will affect global warming, whether you believe in global warming, don't believe in global warming. For us to understand how the oceans are actually emitting is an important problem. And then there's another paper on Kobe where I did a full analysis of Kobe and one on Planck. Now, Dr. Rabunski, who's the editor of Progress in Physics, has been very kind to me. He's taken many, many papers and enabled me to publish my work in what I consider a very new journal. And of course, people say, well, Pierre, why do you publish in Progress in Physics? And that's because it's a proper vehicle for what I'm dealing with now. Now,